In this lesson, we are going to learn how to interpret the Maxwell-Boltzman diagram. So let's look at the axis of the diagram. The y-axis is the number of molecules, and then the x-axis is the velocity. Of course, going this way, the velocities increase. First of all, the molecules in this samples have the same mass number because we are trying to look at the effect of the temperatures on the kinetic energy of molecules. So here we have the equation for the kinetic energy. Now kinetic energy is equal to 1/2 times mv squared. The m is for the mass of the molecules, and then the v is the velocity of the molecules. First of all, in this graph, we are looking at the changes in temperature. You notice 100 degree Kelvin, we have 300 degree Kelvin, and we have 500 degree. The most important part is the range of from here to there for 100 is limited to the velocity. 100 degree Kelvin at the low temperature, the molecule can only travel at this much velocity. Where at the higher temperature, like 500 degree Kelvin, look at the range of this temperature. That means the gas molecule can travel from here and at a very high velocity. So how is that going to affect the kinetic energy? In this case, the mass is the same. So therefore, the mass is not going to change because we are using nitrogen sample. So if we look at the graph, basically it's saying that at the higher temperature, you have a wider range of velocity. So therefore, the molecule can travel higher. So if we have velocity increase, what happened to our kinetic energy? It is also increased as well. Therefore, in this case, we have the relationship between temperature and velocity and kinetic energy. That is, they are directly proportional. If temperature go up, the velocity go up, the kinetic energy go up. If the temperature go down, therefore the velocity will also go down, and therefore the kinetic energy also go down. Here we have another Maxwell-Boltzman diagram. In this case, we are specifically looking at the molar mass of the molecules. For the y-axis is going to be the number of atoms, and for the x-axis again is the velocity. So if we look at this graph, we know there are different molecules. For this diagram, one important information that we need to know is that the different gas that's being recorded here are being recorded at the same temperature. And remember, if it is the same temperature, we are going to have the same amount of total kinetic energy, or at least the average kinetic energy. So all of this gas on here have the same average kinetic energy. And going back to our equation for kinetic energy is equal to 1/2 times mass times velocity squared. The kinetic energy is the same because we have the same temperature. However, we have different gas have different range of velocity. Look at xenon. Xenon has the greatest mass, kinetic energy equal to 1/2 times mv squared. In this case, for a heavier molecules, the mass will be increased, but the velocity would decrease because kinetic energy needs to stay the same. Let's look at a lighter molecules. In this case, we have kinetic energy again equal to 1/2 times mv squared. So the mass is decreasing. Now the kinetic energy needs to stay the same. In order to stay the same, we have to realize that the velocity has to increase because there are only two variables. But in the end, let's use our common sense. If we have something that's heavy, right, therefore it's going to travel slow. If we have something that's extremely light, therefore it's going to travel fast. Now, how is this going to apply to your test question? On the test, I'm going to give you a list of elements with different molar mass, and you are going to identify which of the elements belong to a specific line on the graph.